So, I promised a review of some sort, some tips and hints for our second test in spring 2013 for Physics 132 here at Dominguez Hills, and that's what I'm working at. But instead of making a little presentation file about this, I'm going to do a little tour through some of the stuff that's already sitting around. Basically, I'm going to go to Blackboard and look at some things, and frankly, I have not made up the test yet. So I'm really going to give it to you through the lens of what I'm thinking of when I look through it and remind you of some stuff that I always tell you and how you should look through it. So I go to our course on Blackboard, on the Blackboard webpage, and you know that I put the most interesting stuff usually under info and handouts, particularly those presentation files for what I do every day. And as noted before, I separate them into what's on which test, and this is the second test. So I go there, and my computer is, of course, being very slow for various reasons. I remind you, as I get toward those files, that we moved the tests around. And because we did that, this is covering a little more material than I often would. What's in these files is what's covered on the second test, but when I go later to look at the old tests that are sitting around, I may have to look at both second and third tests. So this is the right set of files, and it's arranged in chronological order from newest to oldest. Day 28 is the last file of new material on that test, so I'm going to scroll down to the bottom. Day 12 is the first file, so that sounds really, really lopsided. There was days 11 back to 1 on the first test, and this is 12 through 28. It's not quite as lopsided as that sounds, but it is more material than you might expect sometimes. Day 12, I put notes on these about the main topics, not every topic, but the main topic. And you can always open the PDFs if you don't have OpenOffice. Day 12 had some conceptual material. It was actually before that first test, but it's material that's only for this test. Really, it was a scattering of material that included some important concepts for now, but not a lot of extra questions, except maybe something like charge polarization. I look at that. It seems like a nice short fact question for me. Day 13 is just a placeholder. That's the day you had the first test. And after it, introduce the concept of electric flux. I should probably give you a problem that asks explicitly to calculate an electric flux. You can find some on old tests. Then we went to Gauss's law, which is a really important way to calculate electric fields. Spent a couple of days introducing it and then talking about problems for it. After that, formal definition of potential, which is voltage, which jumped really quickly into calculations of voltage for arrays of charges, both discrete and continuous, and energy, that is the energy it takes to bring a set of charges together. When I looked at the old tests, most of the time I had some problem that had an array of point charges and asked about the energy necessary to bring those together. And usually, once the array was together, it asks about calculating the electric potential at some region or at some point for that. Did a little more of that on the next day and introduced the mathematical concept of gradient. I told you when I did it, and I told you after that a few times, that that is one of the only places in this class where I will give you an explicit math problem on my physics test that just asks you to calculate a gradient. And I've got that on almost all of the old second tests when I look back. From there, we defined capacitance, calculated capacitance, talked about series and parallel combinations for capacitors, and then what happens when you put material inside a dielectric in the capacitor. Day 22, I actually left you with some sheets to work on. I had told you before that most of my old tests have something about reducing series and parallel combinations of capacitors, and they're on almost all the old tests. I pulled those sheets from old tests that you can find on the Blackboard web pages here. I dropped a big hint after that when I talked about it a couple of times, saying, now that I've tested you on series and parallel combinations of capacitors, I might not want to test you on that, but I'll have other things like resistors. So I think you can really expect already that you're going to get some problem with a big mess of series and parallel combinations of resistors, and reduce those to find the effective resistance. And I even did give a hint that if I could get around to drawing it, and I'm not sure if I can, it might be neat to put one of the same combinations you've seen for capacitors with resistors, and the calculation is different because the rules are different. That said, right after that I got to talking about resistors and combinations of resistors, series and parallel, and electric power. Electric power is a big concept. I could not give this test without giving a question where you needed to calculate electric power either from current times voltage, or current squared times resistance, or voltage squared over resistance for resistive circuits. After that, I put resistors and capacitors together at exponential behavior. Gave a brief introduction to Kirchhoff's laws, or Kirchhoff's rules as I often call them. And then spent a day giving you a lot more information about a microscopic model for current, which I said I won't probably give you a lot of stuff on a test, maybe one simple conceptual question, but then talk more about actually doing problems with Kirchhoff. And I looked at some old tests and some problems and pointed out that I usually don't ask you to do the algebra because the algebra is just a mess, frankly hard for me to grade, and not the point. The last few days of things that are relevant for this test, we talked about starting the topic of magnetism and had a few formulas right away. One called Ampere's law, about the integral of magnetic field around a wire. One that gave the force on a moving charge in a magnetic field, which we quickly changed to the force on a current carrying wire in a magnetic field. Spent a whole day talking about applications of electric charges moving in magnetic fields. A lot of experiments, demonstrations, the concept of something called a galvanometer, which was a device to measure magnetic effects. I note that the galvanometer is what's used in older voltmeters and ammeters, which I talked about in detail, and which I've found on old tests that I looked at. On the last day of new material, I used Ampere's law and a newer rule called the Biot-Savart law for calculating magnetic fields. I did a few examples to calculate magnetic fields, and I gave a lot of emphasis to the difference between those two laws and how they're used, and kind of an analogy of Coulomb versus Gauss and Ampere versus Biot-Savart law. I think I will give you a problem where I ask you to calculate a magnetic field for something other than the things I already showed you. Probably a result you could find somewhere, but I'm thinking that you could apply Ampere's law or the Biot-Savart law and find the magnetic field in some configuration of current carrying wire. I expect to put a problem like that on the test. So that's my quick rundown on the files that are there. Remember that in the info and handouts section, it also has the old tests. As I mentioned a little while ago, we're taking a second test, but you might also want to look quickly at what some of the third tests have to see where they ask you to do things like calculate magnetic fields. And I'll show you an example in a minute. Most of the material will be on the second test, but some of it will be on the third test. The last few years, I've got tests and solutions for the second test. So there's a lot there you can look at and study. Okay. The third test, you may have to be a little judicious on your own about looking and thinking of what is relevant to this. Last year I didn't put a solution up, just didn't get a chance to do it. But the couple of years before that I put up here, I did. So there are a few old tests with solutions that you can look at for third tests. You can always ask me about problems that don't have solutions. I was looking back through my old tests, wanted to give you an example of some interesting things, and I remember I spent a long time in class calculating the magnetic field due to a long straight wire, and I did it for the infinitely long wire with Ampere's law. It was pretty easy. And then I did the same problem with the Biot-Savart law, where it was harder, but I could get answers. I could actually solve it for finitely long wires. And I looked here and I found that I had this really interesting problem in 2011 in the spring, in a third midterm, of a hexagon with a current in it. And this is a fairly hard problem for a test, honestly, but I gave a lot of information in it. You can see a lot of angles are labeled and things, and you can find that test on the front page of the test. I gave some trig stuff that one might need for that, which actually did turn out to be useful. And I think if you can solve that problem, you can probably solve anything I'll throw at you for the Biot-Savart law. On that test, I also had this picture with a galvanometer and a bunch of resistors. I had questions about it. Is it an ammeter, voltmeter, etc.? The solution for this test is up there. You can look at it if you want. Not necessarily claiming I'll have all the same things, but I thought it was interesting that I wanted to give those problems anyway, and then I looked back at the old tests and found that I've used some of them. Last year's test, which is also there, get this stuff out of the way, has an interesting problem which actually can be solved with Ampere's law about what's called a toroidal coil. Don't have a solution for this one up there. Might talk about it in class, but you actually have the tools to solve this already, even though you haven't done the exact problem. There is a twist in here that I wouldn't ask you, and that's about the insertion of the metal in here. And I talk about wrapped around an iron ring. Everything so far has been around an air core. So technically this goes a little further than what I could ask, but it's a pretty similar question to what I might think of. Again, looking back at this, there's a familiar diagram. Showed you that for a few different things. I'm looking at old tests. You might want to look at old tests. I've thumbed through what files I had and what they said, and I've already told you what I think about some of the important parts there. You can skip back in this video and listen to it again if you want. It's not a promise that that's exactly what you'll see, but this is what I'm thinking before I've written the test. Notice I left off a problem about Kirchhoff. It's got a picture with no particular elements in it. It's very conceptual. Doesn't ask you to do any of the algebra, just to draw loops, talk about how many currents, how many equations you need. Of course, this isn't a perfect finish to everything you need for the test, but it ought to make you happy, and if it doesn't, there's a picture of my daughter. She'll make you happy. It's enough time that you can still review things. Remember, you get 1 page of notes, and you can always make your notes early and ask me to review them with you, or ask me to look at the problems with you. I'd wish you luck, but you probably don't need it. So that's all for now. See you on Monday. Bye.